Hi everyone, today we are going to have a look at non-monic quadratic equations. So it's on one level above what we did previously. So last time we looked at the quadratic equation in the form of x squared plus bx plus c equals to 0. And today we'll move on to a more general formulation. So you can no longer take for granted that uh, the lead coefficient equals to 1, so it can be any arbitrary number. And in today's case, it will mostly be larger than 1. This is what we're going to work with. Now, before going into factorization, let's consider what kind of expressions will end up looking like this when you expand them. So if you have two factors, let's say 2x minus 5 times x plus 4. So what happens if we expand them? So we have 2x minus 5, x plus 4. So we end up with 2x squared minus 5x, 8x, and finally negative 20. Yeah. So once you expand them, it will end up looking like 2x squared minus 5x plus 8x minus 20. So if you, at any stage, if you end up with an equation that looks like 2x squared plus 3x minus 20 equals to 0, you can immediately know that this is where this expression came from. So you can just say, oh, factorize it. We factorize into, obviously, what all we had originally. So it should be 2x minus 5 times x plus 4 equal to 0. So just like last time we're solving quadratic equations, you can say either 2x minus 5 equals to 0 or x plus 4 equals to 0. And in this case, 2 times x has to be 5, so x has to be 2.5. And here, x plus 4 equals to 0, so x has to be negative 4. And these are our solutions. So if you know which factors can produce a quadratic equation, a quadratic expression looks like this, then you can just factorize it as it is. But most of the time, we are presented with quadratic equations, you wouldn't know which terms have been expanded to produce it. So, for example, ax squared plus 11x minus 3 equals to 0. So if you have an expression that looks like this, we know that most likely not. Okay, so some of them are not factorizable, but I can tell you now this one is factorizable. So to produce an expression like this, well, at some stage, something like ax plus b times cx plus d equals to 0. I just keep everything general, so I cannot assume that the lead coefficient of either term is 1. And I cannot assume either, okay, they can't be 0 because we have terms here. So just to keep everything as general as possible, we have two expressions, ax plus b times cx plus d equals to 0. So when we expand this, so once this has expanded, it will produce something that looks like this. So let's expand it. So yeah, let's draw the array. It's always good to do it. So when we have ax plus b times cx plus d, so obviously a times c is acx squared. Here is bcx. Here is adx and bd. So it expands into something quite messy, but we'll try to draw the link to the equation we already have soon-ish. So it's acx squared plus bcx plus adx plus bd. Okay, what does this tell us? It tells us that if this equation came from something like this, then the first coefficient, 4, should equal to the product of these two coefficients. Yeah, the two lead coefficients of the two expressions. And then 11 here, the middle term, has to equal to B times C plus A times D. Yeah. So if we want to factorize this, so simplify this a bit. Yeah. So if we draw the linkage, AC has to equal to 4. BC plus AD has to equal to 11. And then finally, BD has to equal to -3. So that's the issue here now. So how do we find what A, B, C, D? What are all these term equal to? Well, we can just basically check all the factors of the first term. So what are the factors of 4? So factors 4, obviously 1, 2, and 4. And we also check factors of -3. So it's just 1 and 3 are the negative. Either one of them is negative. Okay. If you want to just try this in your head, and it can be time consuming. So okay, it's not going to be time consuming for this particular example because there are not many factors for 4 and 3. So 4 has 3 factors and 3 has 2. But if the numbers get complicated, if you have numbers like a lot of factors like 12 or 24, then it can be complicated. Get complicated very quickly if you just try the factors and see which ones check out. So there's a more systematic way to do it. But it relies on the fact that we have to really look at the composition of the middle term. So in this case, we already have it. Yep. Middle term, BC plus AD. So the middle term, BC plus AD has to equal to 11. Now we have, unfortunately, we do not really have a way to figure out what A, B, C, D are respectively. But there's one thing we can exploit. So if you look at this, what's BC times AD? It's just ABCD, isn't it? So where else can we find this product? Can you see that the lead term is AC? And then the final constant term is BD. So if we can multiply AC times BD, it also equals to ABCD. So what we can tell now is that because these two are equal, so whatever BC and AD are respectively, we know that sum have to be 11, and their product have to be the first and the product of the first and last term. So has to equal to 4 times -3. Yeah. So what we're essentially doing is we're trying to go back one step. We're trying to go from, say, 4x. We're trying to go from 4x squared plus 11x minus 3 equals to 0. We're trying to take one step back. We're trying to break it down into 4x squared plus bcx plus adx minus 3 equals to 0. So because once we can break it down, it brings us essentially to this stage. Yeah. So we're going one step back, and then from there onwards, we can factor factorize the first half and the second half and solve it. So now the crux of it is what are AC and AD are respectively. So of course this equals to negative 12. So BC plus AD is 11, and BC times AD has to be negative 12. Yep. Okay, so which two numbers satisfy these two conditions? So what are the factors of 12? 1 and 12, or 3 and 4. So we can see that the two terms will be BC will have to be 12, yeah, and then AD will have to be negative 1. It doesn't really matter which, like order doesn't really matter. You can make AD 12 and BC minus 1 as well. It makes no difference in the end. So from these two conditions, so we know that if we want to break it down, break the middle term into two terms, we have to figure out which two numbers, when you add them, you get 11. And when you multiply them, you get minus 3 times 4, negative 12. So only two numbers satisfy these two conditions because we have two equations. So we have two equations with two unknowns, so they're bound to be two solutions, as we did in simultaneous equations. So we can say, well, BC has to be 12, and we can just write down 4x squared plus 12x minus x, so let's just say 1x, and minus 3 equals to 0. Okay, so we have successfully broken down the middle term. Now we can just factorize everything. So the highest common factor for the first half will be, of course, it's 4x. So we have x plus 3 minus, what's highest common factor here? So it's negative 1. So we have negative 1 times x plus 3 equals to 0. And of course, now we can factor out x plus 3 again. Now, so we have 4x minus 1 times x plus 3 equal to 0. Excellent. So what do we end up with? We end up with either 4x minus 1 equals to 0, which means x. So 4x has to be 1, which means x is a quarter. And then x plus equals to, x plus 3 equals to 0, which means x has to be negative 3. And so there is that. Now, the critical part, as you can see, is try to split the middle term. We're trying to figure out how to split it. And the most important thing is to try to figure out which two numbers add to the middle term, but also multiplies to the product of the first and last terms. Okay, let's try another one. So let's run through the process again. Let's say, let's try something simple. Let's say, so 3x squared plus 13x plus 4 equals to 0. Yeah. So once again, we're trying to split middle term. We want to say have an expression of 3x squared plus bcx. I'm just going to keep the notation plus adx plus 4 equals to 0. Yeah, because this is what we're aiming for. Once we reach this stage, then we can just factorize again and again and then solve everything. So which two numbers can make this whole thing work? So established earlier, they have to add up to the middle term. So BC plus AD has to equal to 13. Yep. And of course, BC times AD, so ABCD has to equal to AB times AC times BD, which is also ABCD. So 3 times 4 equals to 12. Yep. So we are looking for two numbers. They have to add up to 13, and they have to multiply to 12. So which two numbers make this work? Of course, it's 1 and 12. So we can just say, well, we make BC equals to 1 and AD equals to 12. Of course, once again, order doesn't really matter here. So what we can do? Well, we have 3x squared plus 1 plus 12x plus 4 equals to 0. Okay. Now we can factorize everything again. So we have what's the common factor here? So it's x. So it's 3x plus 1 plus what's the, so this is 4. So 3x plus 1 again equals to 0. And of course, we can now factor out 3x plus 1. So we have x plus 4 times 3x plus 1 equals to 0. And of course, x plus 4 equals to 0, which means x equals to minus 4. And 3x plus 1 equals to 0, which means x equals to 3x equals to minus 1, so x is negative a third, because 3 times a third is 1, 3 times a third is negative 1, negative 1 plus 1 is 0. So here are the two solutions. Now, next one. Let's try something slightly harder. Let's say we have 9x squared minus 30x plus 16 equals to 0. Once again, we have to separate it. So 9x squared minus bcx. Sorry, let's say plus. Let's just assume everything's plus. Yep. Plus adx plus 16 equals to 0. So we want to once again look for two numbers where bc plus AD equals to negative 30, yeah? Because BC plus AD has to be negative 30, and simultaneously BC times AD should equal to the first term times last term, which is 9 times 16, which equals to 144. Okay, now, which two numbers satisfy this condition? I'll give you, feel free to pause and think about it. So the quickest way to do it is actually just list out the factors of 144. So 144, which two factors can have a sum. We want to identify which factors, which pair of 144's factors have a difference or a sum of 30. So let's start with the base rate ones, 272. I'm not going to bother with 141 and 141 because it doesn't really do much. 4 and 36 and 6 and 24. Excellent. 6 and 24 because 6 plus 24 is 30. So we can just say, well, BC, because it has to be negative, and so both of them have to be negative. But negative times negative is positive, so it works out. So negative 6 and AD equals to negative 24. So negative 6 plus negative 24 is negative 30, and 6 times 24 is 144. Negative times negative is positive. Excellent. So we found our factors. So we can now separate middle term into 9x squared minus 6x minus 24x plus 16 equals to 0. And what do we have? The first factor here will be, highest common factor will be 3x, yeah, because we have 3x minus 2 left. Here, the highest common factor would be, so when you see negative, generally try to factor out a negative number. So there will be negative 8, because that's the highest common factor between 24 and 16. Sorry. Negative 8, so 3x minus 2 as well, because you're factoring a negative 8 out of positive 16, so you get negative 2, so you end up with 0. And then you can factor out 3x minus 2, so 3x minus 8 times 3x minus 2 equals to 0, which means 3x minus 8 equals to 0, which means x equals to 8 over 3, because 3x equals to 8, so x has to equal to 8. Similarly, 3x minus 2 equals to 0, which means 3x equals to 2, so x has to equal to 2 over 3. And so there is that. One key point to take away is make sure you split middle correctly. You have to be able to identify that when you split middle term, the sum of these two coefficients have to equal to the middle term in the original equation, and then the product between these two coefficients has to equal to the product of the first and last term of the original equation, and that's pretty much it.